Hi and welcome. Some of you have obviously tried to print nuts and bolts in with, how should I say, not very satisfying result. And I did the same, and that's why in fact, made an app where I based some data on the ISO 4035, which is a standard for 60 degrees millimeter threads. I tried to experiment and work a little bit on this until I got some good results when I printed the nut and the bolt. You can't use this with a metal. You can't use a nut with a metal bolt as an example. That will not work very well. So the the thing is, how low could I go? So, and I have only a 0.4 millimeter nozzle in my sidewinder. So I tried really carefully to make a 4 millimeter bolt, but the result was not really great. I guess I should have been down on a 0.2 millimeter nozzle. But when I go up in size, and here is a 6 millimeter as an example, you can see, I don't know if you can see it, but it's really a great result. Here I have, I think it's 8 or 10 millimeter, and it really fits great. Here 22 millimeter is also coming up really great. One thing that I have done is I always print with the same material, the same temperature, and not too hot, but this one is printed in good quality PLA at 195 degrees and with a speed of 45 millimeters per second, which, by the way, is not very fast and much slower than I normally do on my Sidewinder X1, but it gives a good thread and a very nice nuts and bolts. I also tried to print the biggest one I have in the app, and this is the 64 millimeter, and it also came out great. It's a little bit more slack in it, but if you turn it up here, I mean, it's really tight. It's very tight. So let's take a look on the app and design a bolt, and then then print it, and let's take a look afterwards if it fits together. So in the app, you will have the drawing of the bolt, the nut, the M values, which is the thickness of the bolt head or the nut, and the distance between the flat side on the polygon, which also refers to the bolt and the nut. Below here you have the bolt, where we are talking about making the diameter of the bolt. We will use the add method to add the threads, and you will get the dimensions on these 60 degrees triangle, which is equal length on both of them. The same is for the nut. You can also go to this page, which has much less information, and it will tell you the pitch value, the diameter of the bolt. It will tell you the polygon dimensions and the thickness of the bolt head. Here we will see the thread in this expanded or zoomed view. So what you can do is you can choose between these different types of threads. I will probably add more at a time. Maybe I'll do other changes, I don't know, but if you have the link, you will absolutely see it when you try to go in time to time. So let's try to construct a 16 millimeter bolt, and you see immediately you get up some calculations, and I follow them strictly. There's one thing more here. If you want to see where the pitch is 2 millimeter. You just point here, and you see to come this red dot up there. The same you can do otherwise, just to focus in. Well, Here you get most of the data. This is the thread data shown in a picture that is taken from the ISO 4035. These values are not equal to the ISO standard. I modified these by testing out the best way to get a bolt and a nut to fit together when you 3D print them. So let's try to construct these threads on the bolt and the nut. So let's start with that. I use Design Spark Mechanical. I've done this through some years and I'm happy with that. Your preferred CAD program is probably the same procedure. So I have chosen view upside down on the Z-axis, and I will start with the polygon, which has 6 sides. And let me see, it was 24 millimeters and 8 millimeters thick, so we do 24. And we will need the bolt and the other diameter, and you see here this is 12.87. So let's put that in, 12.87. So this is a bolt, and we now need to extract it to the thickness, which was here 8 millimeters. This is exactly the same here. So let's do that. Let's add this tool here, and I click this face now, so I can extract this 8 millimeters. And this face here, do it with this one. This face is the next face we want to extract. So let's do that. We use the pull again. And the first 8 millimeters brings us equal with that face. And then let's go to 32 millimeters. Okay. So now we have the first type of dimension of the bolt. But now I want to cut the bolt in two, so I can start creating the threads. And this is quite easily. I click the center line here, and then I just use the section mode tool, and I got a cut in here. And next step is now to create the triangle here, because we use the add method. This means we will add the thread across the bolt, around the bolt. So let me see what was the this part here we are making now, you see, and this we will construct up here, and this is 1.32 millimeters, and each angle here is 60 degrees. So let's do that. That's quite simple. I take a line tool and I add, here we need to be 90 degrees, what the heck, I already forgot, 1.32 of course, 1.32, 90 degrees, and here we need to be at 60 degrees, 1.32, and 1.32 on 60 degrees. So this is the thread we need to revolve on this bolt, and this is done by, I can use a pull tool, and I mark this face, here you see the revolve. I click that, the axle I want to spin around, it turns blue, and over here you can see I have the add command, and when I push that I get these options to revolve a helix. This gives me a possibility to enter the height. I will just drag it. If you know exactly how long you want it, you can enter it here. A minus value will make the thread down, a plus value will be upstairs. But here I will not do that, but I only want to give the system one information here, and this is the pitch. And the pitch in this case was 2 millimeters, which you see here. So I will enter 2 millimeters there. So now we are ready to make the thread, and I will go and keep my left mouse button down, and now I make the threads by dragging down. And here we are. And that's quite easy, yes? Well, there's only one thing here, and that's we have this tab here. We want to remove that, and that's easily done. I mark this face, and I use the split body function, and it turns light green, and now you can see this what's turning into pink. I click and it's removed, and our bolt is done. Of course you can make the better finish afterwards if you want that, but that's up to you. So this is the bolt we have made, and we now need to do the export, an STL format, and what I will call it, test bolt 1. And we are then ready to make the knot, and we start with exactly the same values. And if you remember here, we had 24 that direction, so we will call it 24 right now, which seems to be, I don't like it, I like it to be there, 24. And again we use a circle. It's exactly same principle as when we make the bolt. And here we have a different diameter. We have 13.42 millimeters in a diameter, which is to this face here. So let's do that. 13.42. There we go. So again we will use the pull tool, and we will again extract this face, and exactly the same dimension, 8 millimeters high. There we go, and we put in an 8. The difference is that this face here we don't need anymore, so I just delete it, which we have done now. And again I take the x-axis, I mark the center line, and I do the cut, and we want to build the triangle on this place here. As you can see here, if I go back here, you can see we want to build it in this direction, and it has to be 1.32 millimeters. So let's make it 1.32, which is exactly the same as the other 1.32, and we go 60 degrees, 1.32, oops, and we should go in here. It should be 1.32 when we close this cap. So I will take the pull tool, so I'm ready to make the thread with the cut command. So I use the pull, but before I do that, I want to mark this face and move it a little bit up, so that I just start in the air and making the thread through the bolt. And that we have done now. Still this face selected. I take the revolve command and the center line again, and now I use the cut command and revolve the helix. We already have, it's the same pitch and it's a 2 millimeters. So let's drag the helix, and you see here now it disappears. It's still making something, but it's just invisible because we cut in the air. But here I'm through, and if we look into the knot, we have this beautiful thread here. So I will export this. So this will just be a test nut, not nuts. And here we go. So now I want to add this to the printer, of course, and this means I need my slicer, which is here. So, and for this project, I take my test bolt, my test nut, and there we go, and I will sort them out. I here have this one. I need my camera there, so I will push it a little bit to the back. So, well, it is not about speed when you are making your bolts, it's about precision, and that's also why this is quite a big bolt, but will take some time. Yeah? So I have a layer height of 0.1. I could maybe go a little bit higher, 0.6, because it's quite a big bolt. I think I will try it in 0.2, honestly. I didn't try that before. And the first layer height will be 2. Yeah. The speed, I keep it down to 45 millimeters per second. The travel I also want. I don't want to shake so much. I do like that. No. Absolutely no supports. There's no need for supports, and you don't want to have supports. This is then the filament settings, and for the filament I start with the first layer of 205 degrees, and then I turn it down to 195. The bed I keep on 60 degrees. Cooling, I keep the fans always on. Yeah, and I have grid settings, nothing there to make. So we are now ready to extrude it. I have an infill here of, let me say, 20% on this demo at least, maybe 25. And we slice it and see how much time it will take. So it will take 1 hour 6 minutes. Makes sense for this bolt. And yeah, let me export it and put it into the So I need some tools here because something happened, and that will happen again. It's not a big deal. My printer was not absolutely correct leveled, and this gave this little elephant foot. And if I do here my bolt, you see it fits perfectly. But I come to the face, which has been placed on the bed. It gets a little bit difficult to get through. So there is a part of an elephant foot in here, so I want to remove that with this tool here. Just cut off the thread inside, or the elephant foot, and now you can see very well. It's absolutely great fit, you see. There's no slack, no nothing. Easily on. Easily off. So have fun with the app. Link is in the description, and well, happy printing. Bye bye.